Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, so our lesson is to understand the simple harmonic equation. So we need to understand the graph of the f and then also the graph of the acceleration. Okay, so we start with this diagram. So we start at the x equal to 0. So this one is a equilibrium point. So at the equilibrium point, so the f is equal to 0. When the f is equal to 0, based on the Newton's second law, so of course the a is equal to 0. Okay, so and then the object is oscillate to the positive x and reach the maximum displacement, actually is a positive amplitude, and then they turn back to the equilibrium point and then go through the negative displacement and then reach the maximum displacement. Here is a negative amplitude, and then they turn back to the equilibrium point, and then the process is a continuing process. So what we need to understand today is the graph of the f and also the graph of the acceleration. So actually the graph of the f and the graph of the a is the same one. Okay, so we go. So we take when the x equal to 0, so the f is 0. So here is the point. Here, when the object reach the maximum displacement, positive amplitude, so is here. The f is a negative, so in this case a maximum. So the f is negative. Why the f is a negative? Because the direction of the f is here. So this means the direction is towards the negative displacement, and then they turn back to the equilibrium point. So they turn back to the equilibrium, and then here when they reach the x is equal to 0, so the force is equal to 0 here, and then they go to the negative displacement. So yeah, then they reach the amplitude. So in this case the f is a maximum, but the displacement is a negative because the direction of the f is here. So this means to the direction of the positive x. Here is the positive x. Okay, to here is a negative displacement. That's why the graph for the f here is a negative displacement, but the f is a positive because the direction is toward the positive x. And then we have the f is from the graph, we have f is directly proportional to negative displacement. Then we rearrange the equation, so we have this equation where k is a constant. Okay, then we go for the graph acceleration against the displacement. Okay, so actually the graph for the acceleration and then the graph of the f, the patterns look the same. Okay, so we need, so when the x is equal to 0 here, so the a is equal to 0. So a is equal to 0. When the object is moving towards the positive displacement, the direction of the f is towards negative displacement. Then the a, when the object reach the positive displacement, so the a here, a is a negative. Why? Because direction of the a is same direction with the f. and then they turn back to the equilibrium point and then reach the equilibrium point. So the A is equal to 0 here. Then they go to the negative displacement. So displacement is negative, but the A is a positive because the direction of the A is to the positive displacement, same like the force. Then they go back to the equilibrium, and then at the equilibrium point A is equal to 0. Okay, so hope we understand the graph relative to this animation. And then we go for the mathematics. From F is equal to the MA and F is equal to negative kx. So from the Newton's second law, so we have this equation. Then we continue, we rearrange equation, and then we have this equation, and then we have this equation. So before we continue, I just need to explain the omega. Omega in this case is the angular frequency, and then the equation for omega is W power of 2 is equal to the K over the M. Then K is a constant, M is a constant. Okay, so we continue. We take the case number 1, and here is a case number 2. Case number 1, actually when the object is at the equilibrium point, so we apply the equation. A is equal to negative omega square x, because x is 0, so we prove here A is 0 when the object at the equilibrium point here and here. So the case number 2, when the object at the positive amplitude, so we apply this equation. So we have here is the A maximum is equal to negative omega power of 2 times the amplitude. That means at the amplitude the A is a maximum. So same with the F also maximum. For at the equilibrium point, A is equal to 0, F also is equal to 0. So we continue. So we have this equation. So because omega square is a constant, so A is directly proportional to the negative x. So definition, so the acceleration A is directly proportional to its displacement from the equilibrium point. So this one is a very important, because this one gives the definition of the simple harmonic motion. What is the simple harmonic motion? So we can say here is the acceleration A of the object is directly proportional to its displacement from a equilibrium point when the object is oscillate. For that, thank you.